Hello, this is your video for Chapter 1 of Statistics on data collection. The first section we're going to talk about in this chapter is Section 1.1, Introduction to the Practice of Statistics. The objectives for this section are 1. To define statistics and statistical thinking. 2. Explain the process of statistics. 3. Distinguish between qualitative and quantitative variables. 4. Distinguish between discrete and continuous variables. And 5. Determine the level of measurement of a variable. So the first objective is to define statistics and statistical thinking. The definition from your textbook for statistics is that statistics is a collection of methods for planning studies and experiments, obtaining information, and then organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the information obtained. In addition, statistics is also about providing a measure of confidence in any conclusions we might come to. Now, the information referred to in the definition is data, and data is simply observations, things like measurements, survey responses, and so on, that describe the characteristics of an individual. In statistics, when we talk about an individual, we don't always mean a person. It depends on the population that we're studying. We may be studying a population made up of people, and in that case, an individual would be a person. But we may be studying a population of fish in a lake, and in that case, the individual would be a fish. Or we may be studying a population of businesses, in which case our individual would be an individual business. Objective 2 is to explain the process of statistics. So when we talk about a population, this would be the entire group that we're interested in finding out information about. So this is going to be usually some type of large group, and for the most part it's going to be too expensive or too time consuming to get information about the entire group. So if that's the case, we select a small group out of our population, and that's called our sample. So our sample is a subset of the population that's being studied. And again, our population is made up of whether they be people or objects or animals. So we have our population, which is the large group. It's made up of individuals. And then the sample is a smaller group that's selected from the population. Now, when we're trying to identify populations and samples, here's some key concepts. If we're talking about a poll or a survey, the sample is the set of all those that were surveyed. The population is always a larger group than the sample. And if the sample is chosen from a group with specific characteristics, then the sample can only represent a population with those same characteristics. For example, if the sample is selected only from U.S. citizens, then the population represented by the sample can only be U.S. citizens. It can't be all people in the United States, since there are people in the United States who are not U.S. citizens. Here's an example. A Nielsen television survey of 4,000 households in the United States finds that 2,988 of them watched the final episode of American Idol. Let's identify the population and the sample. The sample, again, is going to be all of those who were surveyed. So this would be the 4,000 households that were surveyed. Notice, again, this includes all of those surveyed, not just the ones that watched American Idol. So the 2,988 number is data that we collected from our sample, but it is not the entire sample. Now, the population represented by this survey is all households in the United States. In this case, our individuals are households instead of people. So the population that's represented is households in the United States instead of being people in the United States. And also, the sample doesn't represent households in other countries because we only selected from households in the United States. Here's another example. A newspaper article reports that the president's approval rating is 33%, according to a Gallup poll of 1,022 adults in the United States. So again, if we want to identify our sample, the 33% is data that comes from our sample, but that's not in our entire sample. Our sample would be all of those who were surveyed, so it would be the 1,022 adults. The population represented by this survey would be all adults in the United States. Again, that's who our sample was selected from, so this sample does not represent all people in the United States because children weren't included in the selection process. Also, it doesn't represent adults in other countries because, again, the sample was only selected from adults in the United States. Now, sometimes we can obtain information about the entire population, and in this case, instead of being called a sample, this is called a census. It will be very important in later chapters in this course to distinguish between samples and populations and between statistics and parameters. When we talk about a statistic, it's some kind of numerical measurement that we calculate from our sample data. So it's going to describe some characteristic of our sample. So sample and statistic go together, and notice that they both start with the same letter S. If we have a census and we can collect information about the entire population, then any numerical measurement that we get from the census is called a parameter. So a parameter is some type of calculation that gives us a numerical measurement describing a characteristic of a whole population instead of just describing the sample. So population and parameter go together, and notice again that they both start with the same letter P. So if you're trying to remember which word goes with which, just remember that sample and statistic both start with S, population and parameter both start with P. Here's an example. Suppose the percentage of all students on your campus who have a job is 84.9%. Well, here we have a numerical measurement, so we want to determine whether this is a statistic or a parameter. Since this came from data about all students on your campus, that would be coming from a population. So that would make this number, the 84.9%, a parameter. Now suppose we have a sample of 250 students, and from this sample we find that 86.4% of our sample have a job. Well, again, we have a numerical calculation that gave us the 86.4%. That was determined from the sample data, so that would make the 86.4% a statistic. There are two major topics in this course when we're talking about statistics. The first one that we'll talk about in the first few chapters is called descriptive statistics. This just consists of organizing and summarizing data. We'll do that using numerical summaries, tables, and graphs. In the second part of the course, we will talk about inferential statistics. And this uses statistical methods that take results from a sample and extend them to the population. We also have some methods to measure the reliability or the confidence that we have in our results. The third objective for this section is to distinguish between qualitative and quantitative variables in data. So the list of observations a variable assumes is called data. For example, while gender is a variable, the observations, which would be male or female, are actual data. So the first type of data we're going to talk about is quantitative data. And quantitative data always has to be numerical. So this gives us a numerical measure of some characteristic of an individual. We can do arithmetic operations, addition, subtraction, multiplication, and so on quantitative data. And when we do that, we get meaningful results. Some examples of quantitative data would be the number of students taking math courses at ACC this semester, or the ages of hospital patients. The other type of data is qualitative, or sometimes we call this categorical. This gives us a classification of an individual based on some characteristic. In other words, it puts the data into categories. So qualitative data may be in numerical form or it may not. Some examples of qualitative data would be the genders of professional athletes. So we can separate that into two categories, male or female. The rankings of college football teams. Again, we can separate into categories depending on the rankings that they have. And age categories of hospital patients. If we ask them which category they're in, under 18, 18 to 35, 36 to 54, 55 and over, that makes it a qualitative variable or qualitative data instead of being quantitative. Remember back here we were saying that the ages of hospital patients was a quantitative variable. That would be if we asked each patient their age and they just gave us a number. Whereas qualitative would be if we asked them which category of age they were in. So anytime that you are putting values into categories, that makes it a qualitative variable or qualitative data. The fourth objective in this section is to distinguish between discrete and continuous variables. Discrete and continuous are two further separations of quantitative data. So a discrete variable is a quantitative variable that has either a finite number of possible values, so in other words a limited number of possible values, or a countable number of possible values. When we say countable, that means we can actually count the values, 1, 2, 3, and so on. Some examples of discrete variables or discrete data would be a car dealership sold 89 cars last month. We could actually count how many cars they sold. That makes it discrete. Or the number of students enrolled at ACC each semester. Again, we could actually count the students. Or the year that I graduated from high school. Another thing about discrete variables is that there are gaps between the values. So if we talk about the year that I graduated from high school, between say 1996 and 1997, there would be a gap. We couldn't, or in this case we wouldn't say 1996.7. It's not something that we would be measuring. So there would be a gap between each year. So a continuous variable is also a quantitative variable, and this has an infinite number of possible values it can take on, always, and it can be measured to any level of accuracy that we want. Possible values for a continuous variable cover a range of values, so there are no gaps. And continuous variables are measurements. So measurements are always continuous variables, things like heights, weights, temperatures, and time intervals. For example, the actual contents of cola in Coke cans, which are labeled 12 ounces, this would be a continuous variable because the actual contents could be 11 ounces, 11.984 ounces, 12 ounces, 12.0023 ounces, or any other value between 0 ounces and the maximum amount that we could get into a can. So if we could measure the actual contents of each Coke can, there could be any possible number of values for that between 0 and however much a can will actually hold. Some more examples of continuous variables in data would be the amount of time it takes each student in this course to complete the first exam. So this could be 10 minutes, it could be 30.65 minutes if we could actually measure the amount of time each student takes. The heights of 3-year-old elm trees, again this is a measurement, so this would be a continuous variable. Or the weights of the 59 babies born at United Medical Center last month. And note here that the weights are a measurement, so they are continuous data. If we were talking about the number of babies born, that would be discrete data. Objective 5 in this section is to determine the level of measurement. This is another way that we can talk about different types of data. So levels of measurement is another way to classify data, and we define 4 levels of measurement. There are 2 for qualitative data and 2 for quantitative data. The 2 for qualitative data are nominal and ordinal, and the 2 for quantitative data are interval and ratio. So those are our 4 levels of measurement. The nominal level of measurement, and again this is qualitative data. Nominal is another word for name. So this is characterized by data that consists of names, labels, or categories only, where the data can't be arranged in an ordering scheme, such as low to high, poor to excellent, 1 to 5. It can't be put in an order that would make any sense. For example, survey responses such as yes, no, or undecided. There would be no way to put that in an order that would be meaningful. Now the ordinal level of measurement is again qualitative data, and this is also going to be names, labels, or categories, but this has the property that the data can be arranged in an order. Now because this is qualitative data, the differences between data values either we can't determine, or if we can, they don't mean anything. An example of this would be course grade in letter form. So A, B, C, D, or F. Now we can arrange that in order from best to worst, and that has a meaning. But we can't tell, for example, the actual percentage difference between someone who has an A and someone who has a B without getting more information. The interval level of measurement, this is for quantitative data. This has the property that the difference between any 2 data values is meaningful. But with the interval level, there's no natural zero starting point. So there would be no value where we know we would have none of the quantity. And if we do a ratio of 2 values, in other words, if we divide one value by the other, it doesn't make any sense. An example of the interval level would be dates, such as the years 1000, 2000, 1776, and 1492. If we look at the year 0, that doesn't represent no time, And the ratio of the years 2000 and 1000, so if we divide 2000 by 1000 and get 2, that really has no meaning in this context. The last level of measurement is the ratio level. Again, this is quantitative. So this is like the interval level, but it has the additional property that there's also a natural zero starting point. This means that 0 means there's none of the quantity present. And in this case, ratios are meaningful. For example, instead of time as in the year that something happened, if we look at time durations, as in the amount of time you spend taking an exam. 0 represents no time, so that would mean that you spent no time taking the exam. And if one person took 40 minutes and the other person took 20 minutes, if we divide 40 by 20 and get 2, that means that the person who took 40 minutes took twice as long as the person who took 20 minutes. So there's a meaning that we can get out of this ratio.